Hey, this is Mrs. Brookshire. We are working in AP Statistics, Section 1-3. This is part 2. Our part 1, basically, we're going to talk a little bit more about standard deviation. At the end of part 1, we actually went through and calculated the standard deviation, and we talked about how, most of the time you're not going to have to do that by hand. I think it's interesting, and I think it helps you to understand the definition of standard deviation when you do go through and find it by hand. So on this particular section, we're going to go through and talk a little bit more about standard deviation. We're going to make box plots by hand, and also I'm going to show you how to do it in the calculator. We're going to interpret box plots, and we're going to compare distributions. So let's start talking about some facts about standard deviation. That's the first thing we're going to talk about. When would the standard deviation equal 0? Okay, so we know standard deviation is the distance from the mean, so think about that. When the data points are all about the same value, when the data points are all the same value, you would have a standard deviation of 0. And then I have like an example. I said quiz grade. So if you had like 5 quiz grades and they were all hundreds, average would be 100. How far away from the mean would each one be? They would be 0. 0 variation. So that would be an example of when standard deviation would equal 0. Okay? Next question. What do large values of standard deviation mean about the variability of your distribution? So if your standard deviation is large, what does that mean about the variability? Is there a small variability or more variability? Well, a large standard deviation means a high variability. So like instead of having like 100, 100, 100, all hundreds, you might have like 25, 50, 75, 75, and then 100. So you would have, if you took the average, you would have a high variability in a case like that. A large standard deviation means high variability. Is standard deviation considered resistant or non-resistant? All right, so let's think about that. If it's the, like the typical distance from or amount away from the mean, if you had outliers, would that change the standard deviation? Of course it would. So a standard deviation is considered to be non-resistant. The outliers would increase the standard deviation. Okay? So if you took the average, those outliers would be further from the mean. So that would increase your standard deviation. What does standard deviation measure? The variation from the mean. Or another way you could say it would be the typical distance away from the mean. So it's the typical distance away from the mean, or the variation from the mean. When should I use standard deviation? Okay, so we talked about, like in the last section, like when do you use mean or when do you use median? And we talked about really you should make sure and use median, like if those are measures of center, but if you have outliers, you should use a median because a mean is non-resistant and therefore it's going to change with outliers. So what about standard deviation? Only use this when the mean is chosen as a measure for center. So if you say, hey, I have symmetrical distribution here, I'm going to use mean as my measure of center. So if you do that, that is when you would also use the standard deviation as your measure of variability. Okay? How do I interpret standard deviation? Let's use the example from how many close friends do you have? And I think we had written this down before, but we'll write it again. So if I told you the mean number of close friends that you have is 3 and the standard deviation of 1.28, interpret, this is what is important because they're going to ask you to do this. So what I said is the number of close friends these students have typically varies by about 1.28 friends from the mean number of 3 friends. So you need to put it in context, and you need to kind of explain that that's what standard deviation is in this particular situation. So I did use the mean number, I did use the standard deviation in my explanation to interpret. So the number of close friends these students have. So if you think about all these answers, so the number of close friends these students have typically varies by about 1.28 friends from the mean number of 3 friends. So that's how you would interpret standard deviation. Make sure it's in context. And you always would say, you know, that it typically varies by the standard deviation from the mean number of, and all of it's in context. Okay, so the next thing we're going to look at is we are going to look at the standard deviations and histograms. So if we have a histogram. And so what you're supposed to do is you're supposed to order the histograms from smallest to largest. So I want you to think about it. And the marked is the balance point. Okay, so there's your balance point on each one. Which one of these do you think would have the highest standard deviation, the least standard deviation, and I guess the middle of the road? So we're going to order them. I'm going to let you think about it for a second. Okay, to me, if you look at this one right here, there's the balancing point. And this one is actually going to have the smallest standard deviation. Okay. And the reason is because if you look, I mean, obviously there's variation, but the further you get from the middle or the balance point, the less amount of, you know, the smaller amount it is in each one that as it goes away. So I would say it's the smallest, and it really is due to there's lower frequency in the tails. Due to lower frequency in the tails. Okay, so that's why that one would have the smallest. Look at the frequency in these tails. So if this is the middle, the further you get, the more there are in each bar. So this one actually has the highest standard deviation. And it's due to higher frequency in tails. Due to higher frequency in the tails. So you've got the smallest, the highest, and then this one would be in the middle. Okay. How far is the data from your balance point? The higher frequency in tails will increase the standard deviation, which is kind of what we just went through and described. So if you're looking at a histogram, that's what you're looking at. How much is in the tails? All right, we're going to go through now. We're going to talk about what are quartiles. We talked a little bit about this last video. First quartile, third quartile. Okay, so quartile, you know, the definition, okay, we got a couple of definitions. So what is a quartile? The quartiles of a distribution divide the ordered data into 4 groups. Okay, that's the prefix QUAR. Having roughly the same number of values. To find the quartiles, arrange the data values from smallest to largest. Find the median. So the first quartile is the median of the data to the left of the original median. And the third quartile is the median of the upper values, I guess you would say. And then the IQR is really easy. How do you find the interquartile range? It's the distance between the first and the third quartiles. Okay? So if we want to go, if we look at this box plot here, or we look at this dot plot, and this becomes the box, the box plot becomes the dot. Let's say that backwards. The dot plot becomes the box plot. So this is fuel economy. And whenever you are finding, if you want to make a box plot, you've got to have Q1, you've got to have the median, you've got to have Q3, you've got to have the min and the max. And that's what makes the box plot. And you also have to find the outliers, and we're going to talk about how to do that as well. So what you want to do is you want to take your data and you want to find the median. So it says the median is 22.4. Okay, so there, from this point, you want to find the median of this data, the bottom part. And when you find that, that's Q1. So that's the median of the lower data. And then Q3 is the median of the upper data. Okay, and so this is a minimum. Minimum is the lowest value, maximum is the upper value. All right, so let's first of all talk about when you take and you change your dot plot. And a lot of times you'll have your numbers listed out and you'll go find the median, and then you go to the bottom set and you find that median, so that's Q1. And then you go to the upper part and you find that median, that's Q3. And then the median is also sometimes called Q2. So you go in on a box plot and it's basically a number line, and you put the median goes in the middle, and this is Q1, this is Q3. Now you do have a min and a max, but they appear to be outliers. Okay, so the next thing we're going to talk about is how do you figure out, if you have an outlier. There is actually a formula that you will have to use to determine if you have an outlier or not. Okay, and this is the formula. To find the lower outliers, you take whatever Q1 is and you minus 1.5 times the IQR. So you've got to have these values. Okay, you've got to have Q1. To find the IQR, that's the formula. So the interquartile range is just the distance between the first and the third quartiles. Okay, so first you find the median, you find Q1, you can't find Q3, then you can find the IQR, and then this is how you find the outliers. And then the upper one is you're going to take your Q3 and plus 1.5 times the IQR. Okay, so that's how they found out that we have these outliers here. Okay, another thing I want to point out, when you divide these up, 25% of the data, that's what a quartile is in the first quartile. So that's 25% of the data. 25% of the data is in the second quartile. 25% is in the third. And then 25% is in this top part. So if you divided all the data, if you divide it up into fours, there's your 25, 25, 25, 25. Okay? So what we're going to do is we're going to go practice making a box plot. All right? And so that's kind of what we're going to work on this next page. So we have picking pumpkins. Some students purchased a pumpkin for a carving contest. Before the contest began, they weighed the pumpkin. The weights in pounds are shown here. So how do you make a box plot? Okay, I am going to show you how to put it in the calculator, but we are, let's see. First thing you got to do is find the 5-number summary for the distributions. So what the 5-number summary is, we'll show you. Then you got to identify the outliers, draw and label the axis, scale the axis, draw a box that spans from the first quartile to the third, mark the median, draw the whiskers, and that comes from the largest and the smallest data values. Mark any outliers with a special symbol such as an asterisk. So box plots will not show each data point. This is kind of a downfall of these, because it does not show each data point as a dot plot does, okay? And it cannot show gaps or clusters. So these are kind of some things you need to keep in mind. Make a box plot of the pumpkin weights. Okay, I think most of you guys are probably going to use the calculator to do this. If you didn't use the calculator, this is what you'd have to do. You'd have to go put all these numbers in order. So you'd list them out. You'd go find the median. Okay, once you find the median, the numbers underneath, you would find the median of them. And that's going to be your Q1. Then you would find the median of the upper values, and that's going to be your Q3. Okay, so you can go through and do it by hand. I'm going to have stop for a second and let you go and enter this data in list 1 in your calculator. So let's stop the video for a second and do that. And then when we come back, we'll make a box plot. We'll come up with, I'll show you the 5-number summary. And then okay, hopefully you've got your data in list 1. So now let's talk about how we can use this to make a box plot. First of all, I do want to tell you, you could go to Stat Calc and you could go to various statistics, and it will list your 5 number summary, which is the min, Q1, the median, Q3, and the maximum. Okay, so you could get that data from there. The other thing, though, is you do have to calculate what if you have an outlier. So what I'm going to have you do is let's go in and write down the 5-number summary, which is min, and that was 2. And then we have Q1, which was 4. Q2, which is also, I'm sorry, sometimes it's called Q2, or it's the median, which is 6.6. And then Q3, when we looked at our data, was 12.7. And then the max was 33. So there are our 5-number summary. Now what we want to do is we need to go see if there's any outliers. Now I have a suspicion that that 33 may be an outlier, okay? Maybe the 31, or some, there could be others. But to me, those kind of seem like they probably are. So we're going to use the formula, okay? The first thing you need to do is you need to find the IQR. And the way you find the IQR is Q3 minus Q1. And we have those values. So Q3 is 12.7, Q1 is 4. And that's equal to 8.7. So that's the first thing you do, okay? So then to find the outliers, okay, I'm going to write down the formula. It was Q1 minus 1.5 times the IQR. So we're going to just sub the numbers in. So Q1 was 4, and then minus 1.5 times 8.7. And when you do the math there, put that in the calculator, you get negative 9.05. Okay, we do not have any values that are negative 9.05 or below. So there are no lower outliers. Okay, no lower ones. So then we need to check on the upper one, which is Q3 plus 1.5 times the IQR. So when you go through and you sub in Q3, that was 12.7 plus 1.5 times 8.7. Now you do need to memorize this formula. You need to know how to find the IQR, which is Q3 minus Q1, and you need to know how to find those outlier formulas. They are not on the formula sheet, and you are asked to do that quite often. So 25.75. So what this says is if you have a value that is 25.75 or above, they are outliers. And when I look through the data, I see 2 points right here that are above 25.75, which means they are outliers, okay? So what I'm going to do, let's make our box and whiskers. We're going to number from 0, and I'm just going to make little dashes here. 1, 2, 3, 4, there's 5, a number line. 1, 2, 3, 4, 10, 1, 2, 3, 4, 15, 1, 2, 3, 4, 20, 1, 2, 3, 4, 25, 1, 2, 3, 4, 30, and then a couple more, okay? Because we got to get up to 33 so we can put our outliers on here. So when we make our box and whisker, these 2 points are outliers. So you're just going to put a point here, and you're just going to, or you could put a star, or you could put an asterisk, whatever you want to do. So those are outliers, okay? So those are the only 2 individual points we need to graph. So our least value, what is the smallest value? It is 2, okay? So our smallest value is 2. Q1 is 4. That's the lower part of the box. Q2, or the median, is 6.6. That's the middle. And then 12.7 would be the upper part. Okay, so there's Q1, there's the median, there's Q3. So the interquartile range is kind of interesting. It's actually the range of the box. So it is a number, though. It's Q3 minus Q1. So we're going to connect this. Now, the other part, we can't use these two values, so you've got to find the number right under that, which would be, I believe, 15 would be the next number under that. So that's going to be what we use there. So there we go. There's your box and whisker. Now, instead of us doing all this work, but you really do need to know how to find the outliers. Okay, you need to know those formulas. You need to know how to find the IQR. What you can do in your calculator, now we already have the data in. Stat edit, there's our data. You can go to your stat plot, turn it on, and you want to go, not a scatter plot, but you want to go down to this one with the outliers. There's your box plot, or sometimes it's called box and whiskers. Hit graph, and then push zoom 9, and it'll make it fit your data. What you can then do is hit trace, and you can actually, there's our minimum, 2. There's our Q1, 4. There's our median, 6.6. There's 12.7. And then there's our 15, and there's our 2 outliers. So if you hit trace and then you just arrow, you can get each of those values there too. So that's how you make a box plot. Okay? All right, so it says, what measures of center and measure of spread should be used with this distribution? Okay, so because you have outliers, you would not want to use the mean, okay? So you would use the median, and because you don't use the mean, you don't use the standard deviation. The only time you use the standard deviation would be if you use the mean. But since we are not using that, we're going to use our... So it says, what measures of center and measures of spread? So at this point, I'm just going to put my little note sheet up here. So the measure of center would be your median, and the measure of spread would be your IQR. Okay, you wouldn't want to use range because you have outliers. You wouldn't want to use standard deviation because you have outliers. So you want to use your median and your IQR because they're both non-resistant. Because the box plot is skewed right and it has outliers. Okay. So if you look at the data, if you look at this, it is skewed right and it does have outliers. So those would be the two. So sometimes they're going to ask you, like, what measure of center? So do you use median or mean? And what measure of spread? Do you use... you could either use range, you could use standard deviation, or you could use interquartile range, and that's what you would want to use, the IQR. Because think about it, that this part of it, the IQR, the length of the box basically, from Q3 minus Q1 is not going to be affected by outliers. Describe the distribution. So this is where you want to do your socks. So you want to do shape, outliers, the distribution. So we're going to describe this. The distribution of pumpkin weights is skewed to the, don't forget to put it in context, skewed to the right with 2 upper outliers at 31 and 33. The median weight of the pumpkins chosen is 6.6 pounds and the IQR is 8.7. Okay, so the IQR is actually sort of the range of the box, and it is a number. So we just describe the distribution. Anytime it says that, you're going to remember your socks. Shape, outlier, center, spread. Okay, next question. In a recent year, Consumer Reports rated many tablet computers for performance and quality based on several variables. The magazine gave each tablet an overall rating, where higher scores indicate better ratings. The overall ratings of the tablets produced by Apple and Samsung are given here, along with parallel box plots and a numerical summary. So here is what we have. Let's see what we have here. This is the Apple, this is the Samsung, and then here is an example. This is what a parallel box plot is. It's just that you have two basically box plots on the same number line and the overall rating. So here was the Apple, here was the Samsung. Okay, a couple things I noticed. One, this one has more variability, okay, than the other. This one does have some outliers. Overall rating, this one, to me, the Apple seems to have a better overall rating if you look at the median for both of them and then how much data is below. So it says compare the distributions. So when you compare the distributions, you want to compare them as you're doing your SOCs, okay? So the distributions of both Apple tablets and Samsung tablets are skewed to the left. So they are both skewed to the left. The Apple tablet has two lower outliers and the Samsung tablet does not have any. So notice we're doing SOCs as we're comparing them. The median for the Apple tablet is slightly higher than the Samsung tablet. Notice you don't have to tell a number, you can look at it and tell this is higher than this. The Samsung tablet has a much higher variability, which I kind of like. That was one of the things that stuck out to me, than the Apple tablet. The variability and lower variable of Samsung's overall rating makes it a concern to buy. Okay, so that would be how you could compare, or how you should compare your two distributions. So you are doing SOCs, but as you go, you're also comparing the two. Or you're telling how they're the same. Okay, so the variability, this is an issue for Samsung. And also, the variability and lower variable of Samsung's overall rating makes it a concern to buy. So there's kind of a conclusion sentence there as well. Okay, that wraps it up for section 1-3, part 2.